Okay, so this lesson is on basic factoring, so GCFs and basically those types of things, not on trinomial and polynomial factoring like FOIL. Okay, so if we have 15 n to the third minus 11 n squared. So this is basically factoring out common things, okay? So the first thing we want to look at is the numbers. 15 and 11, well, they don't have anything in common. For one thing, because 11's prime, right? So that means the numbers don't have anything in common, so we can't factor any of them out. However, the variables do have things in common, right? They're both n's, meaning we can factor at least one n out, but we can factor out kind of as many as we can. That's what we're going to look for. This term has 3 n's, this term has 2 n's. So they both have at least 2 n's in common. So n squared can be factored out, meaning what's left? Always remember that factoring is just kind of like division. So if we divide 15n cubed by n squared, we're left with 15n. If we divide 11n squared by n squared, we're left with 11. Okay, so always remember too, you can check this very easily by just multiplying the n squared back through. You should always get back to what you started with. Okay, so that's the kind of first basic factoring that we can do. The next kind of version is where we have a little bit more to it. So if we have a problem like 25 u to the fourth x cubed y squared minus 15, not x yet, u to the eighth x to the ninth. So again, look for commonalities. 25 and 15, always start with the number. So 25 and 15, well, they both have a 5 in common, right? Now look at the next variable, u. So this one has 4 u's, this one has 8 u's. That means they both have at least 4 u's. Okay, so next variable, x's. This one has 3, this one has 9. That means they both have at least 3. Now this term has a y, but this one doesn't have a y. That means that because they both do not have it, it cannot be factored out. So this is everything that can be factored out. So then what's left? 25 divided by 5 is 5. U to the fourth, take away 4, well, that's no u's. X cubed, take away 3 x's, no x's. Y squared, take away no y's, so y squared. Minus 15 divided by 5 is 3. U to the eighth, take away u to the fourth, that's u to the fourth left. X to the ninth, take away 3 x's, that's x to the sixth. Remember, division of variables is like subtraction, with the exponents at least. So again, we could multiply this back through times both terms distributed, and we would get back to our original question. Okay, so from here, if we want to kind of take it a step further again, so like, let's see, if we have something like 7x times x plus 8 minus 3 times x plus 8. Well, again, we're looking for commonalities. So let's look at the first parts outside of the parentheses first. 7 and 3, nothing in common. There's an x on here, there isn't an x here. So the outsides don't have anything in common. Now we notice they have the same factor group, right? So because it's in both terms by multiplication, that means we can factor it out. If we factor x plus 8 out, well, we're left in each term with what? Well, this one, if we take away the x plus 8, we're left with 7x. This term, take away the x plus 8, we're left with minus 3. Okay? So this is kind of what we call the last step of a factor by grouping method. Okay, we'll get into that more in one of the other videos where I talk about different ways of trinomial factoring, like FOIL and things like that. Okay, so basically what we need to remember here is look for commonalities, okay? GCFs is just greatest common factor, what they all have in common, okay? Now, what we've done here has always just been kind of an expression where it's a plus or minus in between the different terms. You can be asked for GCFs of just terms, just one term, comma, another term, comma, another term, right? And you're still just looking for the commonalities. You wouldn't write it out like a factored thing though, okay? You would just say, this is the GCF. So it's a little bit different, but you think about it the exact same way. All right, so that's the basics of factoring.